Mirroring is a concept you must be aware. If you're not aware, kindly go and look at my video on mirroring as a concept, which was introduced in the storage fundamentals. Mirroring is implemented in the form of redundancy in ASM. What is the objective of redundancy, or what is the objective of mirroring in a typical storage server? Pretty simple. Ensure high availability of my data. Disks are bound to fail. You can't say when they will fail, they can just fail. But just because a disk fails, I don't want my database to be affected. I don't want my applications to be affected. So what storage vendors did is they brought about a storage array, created a LUN out of it, and they implemented mirroring at the storage level, which could be called as RAID, through which fault tolerance was implemented. In the case of ASM, we have something called as redundancy. Redundancy is of three types. Number one, you could have external. Number two, normal. And number three, high. If you are using ASM with the disks managed by the storage layer and a volume manager, and you want a LUN to be created out of it and provided to ASM, there is a high likelihood that mirroring is already implemented in the storage layer. If mirroring is already implemented in the storage layer, then you don't want ASM to also duplicate data. So you don't want ASM to duplicate data, you provide external. Number two, normal. When you implement redundancy at a level of normal, then it means whenever a data file is put into a disk group, it will maintain two copies. Now it doesn't maintain an entire file copy in two disks. That is how a typical mirroring could have happened. But what happens here is, remember, it is striped. Striping is anyway happening, but then when a stripe is written to a particular disk, a copy of the stripe will be put in another disk in the same disk group. This is the default behavior of ASM, wherein a primary copy of a stripe and a secondary copy of a stripe, in the case of normal redundancy, will be maintained on two different disks within the same disk group. Remember, redundancy is within a disk group. It is not between two disk groups. So what is the benefit? In case one disk fails, all the stripes that are present within that disk would be present in some other disk. So as far as your disk group is concerned, it will ensure the data is available as far as just one disk fails. You are now fault tolerant with respect to one failure of a hard disk. But what if a second disk fails in the same disk group at the same time? We can't guarantee availability, because it may happen that it still provides availability, but there is no guarantee. What do I do then? You either have to bring in a backup, or you go for high redundancy. When we implement high redundancy, for every stripe that is implemented, two additional copies are kept, which means 3 copies of the data is going to be kept. So if you put a 1 GB file in the storage, 3 GB will be written, because there's going to be a primary copy, a secondary copy, and a tertiary copy. Very similar to the way normal redundancy was done. It's just that instead of maintaining 2 copies, which happened in normal redundancy, in high it maintains 3 copies. With 3 copies in place, each stripe would be present in 3 different disks, as you can see in the diagram. So thereby, if the first disk fails, or if one disk fails, 2 more stripes are available across 2 other disks. But if a second disk fails, I still have my stripes available. So I can tolerate up to 2 faults. And in the default mechanism of ASM, I can tolerate up to 2 disk failures. So the idea behind implementing redundancy is to ensure high availability of your disk groups, or rather high availability of your data in your disk groups, and thereby you don't need to necessarily go about doing a backup and recovery situation. Whenever a disk fails, your data is highly available. The primary benefit of redundancy is to ensure how many faults you can tolerate. If you want to tolerate 2 faults, you need to have high redundancy. If you want to tolerate just 1 fault, then you implement normal. And if you want the fault tolerance to be taken care by the storage layer itself, at ASM you just specify external redundancy. So this is how redundancy is implemented in ASM.